today we're talking about break-even points or equilibrium points. So that is our subject for today. So we're going to use a linear model. To find break-even points. Okay, so we've got this first problem here. We've got a company manufacturing a product. We're going to change the cost here. We want it to just be 65 cents. So instead of 0.065, just make it 0.65. Okay. And then they sell the product for $1.20 per unit. And the initial investment to make this product was $10,000. So we're going to use a linear equation here, just your basic slope-intercept equation, to write a model for the cost of the product. So we've got three values here, 65 cents, $1.20, and 10,000. Which one has no part of the cost of making this product? Yeah, $1.20. That's what you're selling it for, so that's going to come into play with the revenue. The other two matter. So our equation here that we're looking at, your cost is equal to, we have something times x, which is the number of products, and then plus some just constant value. What do you think? Which one, the 65 cents or the 10,000? Which one is your slope?
65 cents.
10,000 would be crazy. Yeah. 65 cents. So it is 65 cents each time we make one, whatever this product is. But then we had that startup cost of $10,000. Okay. So your y-intercept is that 0, 10,000. And then the 0.65, that's your slope. Okay. Make sense? Okay. So then part B, I'm asking you what's the cost of making 18,000 of these. So what do we do? Okay, I'm asking what is the cost? So we're going to solve for C. Where do I plug in the 18,000? Yep, so 0.65 times 18,000 plus 10,000. So what do we get? Around 22,000, maybe like 21,700. Okay. So that's our cost, 21,700. If we make 18,000 of whatever this product is. Okay, so then we're going to write another equation to model the revenue. So we're going to have revenue equals, we know we sell them for $1.20 per unit. What do you think that $1.20 is? Yeah, that's your slope, okay? So we have 1.2x. With our cost, we also had like this initial investment of 10,000. Do we have any sort of initial revenue? No, you don't make revenue until you sell them. So there's nothing else there. So that's your entire equation, is revenue equals 1.2x. So what is our revenue for selling 18,000? Yeah, $21,600. So is the company going to break even selling 18,000 of these? No, you have not sold enough yet to break even. So no. What will their loss be? Yep. So no, they will have a loss. $100. Okay. So we need to figure out how many they have to sell to actually break even. So what do you think we're going to need to do?
Put it into our calculator.
Okay, what are we putting in?
First order is one and one order, one, two.
And see where they intersect? That is absolutely one way to do it, yes. Because you're trying to figure out when do the cost and the revenue equal the same amount, okay?
You just divide the difference by the price of the product itself. The difference in the paper. So if you need to, actually never mind,
Set them to each other.
Yeah, just set them equal to each other. So anytime you're trying to find your break-even point, you're just setting your two equations equal. So 0.65x plus 10,000 has to equal your 1.2x. Then it's just algebra 1 here. But tell me what you said, like put one of them in y1, the other one in y2, find where they intersect, that's fine. Sometimes, like, your window gets crazy because these are such big numbers, but absolutely works. Okay. So let's see, what do you guys come up with for x?
It's hard.
It should be more than 18,000, right? Okay, because we know that wasn't enough, so. 18. No, here, it's just a little more than 18,000. Is it 81 point something? Yeah. So we need to actually go to 18,182. Okay. So when you solve, you guys are getting 181 point whatever. If you round down to 18,181, that is not going to be quite enough to break even. So if we round it to 18,182, you definitely made enough. You'll have a teeny tiny little profit, but you won't have a loss anymore. We can't make part of a product and sell it, okay? It's like any of those word problems with people. You can't have like 2 tenths of a person. It doesn't work.
2 arms.
Yeah. Okay, so break-even point, we are just saying total cost equals total revenue. And you guys understand revenue's not your profit, right?
Yeah.
Okay, just making sure we're good with that. So we okay, break-even point? Not too hard, right? Okay. You can show this in these different manners, algebraically, graphically. We're not going to do anything numerically with it. Algebraically is what we just did, where you set them equal and solve. Graphically is where you graph them and find the intersection. That's it. Okay, so let's change it a little. How many units does the company have to sell to break even if they sell them for $1.45 each instead of $1.20? So think about if your cost equation changes or your revenue equation or both, what do you do? We are setting up here 0.65x plus 10,000 equals equals 1.45x. And guys, just looking at it, think about like whether your answer makes sense or not. If we're raising the price of what we're selling them for, should we have to make more or less units? Less, okay. And did you get an answer that was less?
Yeah.
Yes, what'd you get?
12,500.
Lovely, 12,500 units, okay. Anybody questions so far? Okay, let's turn the page. Oh, yeah. No, you're fine. Yeah, just speak up if I ever go too quickly.
I'm good.
Yeah? Okay. All right, we're going to talk a little supply and demand here, guys. All right, so your supply equation, all we're looking at here is the relationship between unit price which is your Y, and quantity, which is your X. And then the way we look at demand, it's the relationship between unit price which is your Y, and quantity and demand, which is your X. I'm not going to draw any pictures just yet. You guys talk about supply and demand all the time, right? Like you have a good understanding of the basic idea there.
Yes.
Okay, so we've got Hurricane Irma coming to Florida, right? You guys hear what Amazon has done with the price of water? It went way up. Yes, it's like 32 times what it was before the hurricane was coming. Yeah, that's a little bit of price gouging. Doesn't seem appropriate. Because the demand is so high, and I don't know how their supply is doing with Amazon. It looks like they have supply of everything. But so they are charging an absurd amount for water now.
I know Katie lives in Florida right now, and he sent a video of Walmart, and the shelves are just
Just
clear.
empty, yeah. Yep. I know you see footage of like people at the gas stations, just the crazy lines. So same thing with gas. You know, the refineries because of Harvey. So what's going to happen to our gas prices? They already have less supply, yeah. So this is very basic, real world stuff. You just get to solve equations with it. All right, so your equilibrium point, if you hear that, this is when your supply equals your demand, okay? It's called a point because it's actually to be an ordered pair. So you need an X and a Y when you tell me about the equilibrium point. All right, so let's look at the first one here. So they're giving you your demand and your supply equations. Remember, those are just two different ways to say Y when we talked about it up here. We've got our quantity, and demand, quantity, and supply, but these are both just our Y's, okay? We're talking money again. we have to find the equilibrium point. So what do you think I'm going to do with these two equations? Set them equal. Because equilibrium is supply and demand are the same. So we're going to do 195 minus 5.8x equals 150 plus 3.2x. So then we are in algebra 1. You guys solve it, tell me what you get for x. Yep, perfect. X equals 5 units. Everybody there? Okay. Now if we're talking about equilibrium point, remember I said you need an X and a Y. So we've got our X. We need to find our Y. How are you going to find Y? Plug it in. Does it matter if you use demand or supply? No, you just set them equal to each other, so they're equivalent. So I do not care which one you plug it into. All right, so your equilibrium point is 5 units. And it happens at $166, okay? All right, so you guys try the next one. The demand and supply equations are given for streaming media devices. See what you come up with your equilibrium point here. Guys, do we have a point? We're not quite yet. What's our point? What's our equilibrium point? 4 units, good. What did you say, 90?
I said 99.
99? Is that, are we in agreement? Okay. Questions? Anybody? Don't be shy. Let's keep going. All right, so we sort of have a second lesson today. We're going to talk a lot about slope in the real world. All right, so we are just going to interpret and use slope. So I have a whole lot of blanks here for what slope can equal. What do you guys remember about slope?
Changing y or changing x.
What else? Rise over run. What about the formula for it? Over. Symbolically, sometimes you'll see this little triangle y over triangle x. That's actually delta y over delta x. The delta means change in. You can even just think of it as vertical over horizontal. All right, so now we're going to talk about ramps. So the steepest, that's what the maximum recommended slope is for a wheelchair ramp, is 1/12. So if you ever own something, a business, anything like that, there's width requirements, there's slope requirements for all of the handicap accessible things, it's the ADA compliance. So you have to be very aware of what the steepness of your ramp is. Makes sense that you wouldn't want it too steep, right? Okay. Yeah, wouldn't be very easy in a wheelchair. All right, so we have a business that installs their wheelchair ramp, and it's 22 inches high over 24 feet long. So we need to decide if this ramp is okay or if it is too steep. Anything you notice right away that we might have to think about?
Chase the feet to inches.
Yeah, because we've got vertical in inches there, but horizontal in feet. So how many inches is 24 feet? 288 good. Okay, so then the slope of our ramp here, what would we set up? 22 over 288. And that's approximately what decimal? Yeah, I have 0.076 written down, so. Okay, we are comparing that to 0.083. What do you think? Is this business okay, or are they in trouble?
It's good.
Oh, okay, disagreement between Thomas and Tommy. He says they're good, you say not good. Why do you say not good?
Lower. No.
So if it's lower, your ramp is just less steep. Is that okay?
That's just the maximum.
So the maximum steepness is 0.083. You're at 0.076. Does that make sense? So you're a little bit less steep. It's okay. You're making a longer ramp than you really have to, but it's okay. All right. So there, the ramp is okay. All right. So you guys try B. Apparently, the same business has a second ramp. You need to decide if this one is okay or not. I finally got batteries. These are the crappy ones, though. It'll work for what we're doing today, but it's not fun for like the regression and stuff. walking around, it looked like you set this up right. We are checking 27 over 312, and you get approximately 0.087. Yes, okay. Is that okay or not okay?
Okay. Or not okay.
Okay. So yeah, the answer to the question is yes, it's steeper than recommended, okay? So the ramp is too steep. Okay, so the next one, we're going to write an equation. That's called point slope form. The y minus y1 equals m times x minus x1. X is our horizontal distance, y is the vertical distance. And this is talking about for ramps that are okay. So from the recommendation up here, we're going to use the slope of 112. So we're talking about the recommended distance. Now the easiest way to do this is just think, if I start at the origin, and there's my ramp, there's my x, there's my y, right? Well, you've gone over 12, and you go up 1, okay? And what is that starting point there? What would the ordered pair be for the origins? 0, 0. So super easy if you start from there, because you're just doing y minus 0 equals 112 times x minus 0. Okay, so it's just y equals 112x. That's just an equation that represents the slope that is appropriate for OK. All right, so D, how long should a ramp be to go up 3 stairs? Well, we need to know how tall a stair is. I believe a step is about 7 inches. So, let's see if we can figure out. I'm sorry, how far you have to go horizontally. Make yourself a picture. Start up for 1 step first if you want to. So the slope is 112. That's if 1 step is 1 inch. How tall is your step? Struggling a little on this one? Okay, so let's think about it. So this picture right here, this is just showing the appropriate slope of the line. That slope could continue along here. I'm not looking at a step being 1 inch high now. I'm looking at it being 7 inches high. So this has changed. So you got to think about what is going to happen here. So let's use our equation here. So that's now 7 instead of 1. And we don't know this. Okay. So you could still use this equation from up above. Do I know the x or do I know the y?
Why?
Yeah, so 7 equals 1/12 x. So how do you solve for x? Yep. What is 7 times 12? That is for one step. I want 3 steps. So what do I have to do with that? What? Yep. 252, which is do you ever walk up a set of stairs that is not set to the right slope or the right width of the stair? You will absolutely trip and notice that they're wrong because you are so used to steps being the exact same width and height everywhere. So has anyone ever tripped on stairs that are clearly not the right? It's like too small. Yeah.
That's funny.
Your body gets so used to it. Yeah. All right. So the second part of this, could your ramp be longer than the value that you found? What do you think? Could we make it even longer on a ramp here?
Yes.
Yeah, because what if it gets longer? What does that do to the steepness of it?
That decreases.
Yeah, it just makes it less. You have a really long ramp, but it's not going up as steep. Right. So, yes. Yes, it could be longer. Okay, we are not going to go measure any of the wheelchair ramps today. We might actually do that next week. We'll see. We'll just see how our time works out. So go ahead and turn the page for me. Yeah, we can check and see if Madison is in compliance with the rules.
We gotta write them a ticket if they're not.
We got to do that at the end of this year.
What, water?
The Waterloo thing, we never did that last year.
Oh, you guys got gypped, didn't you?
Yeah.
Did you guys?
Yeah, I think so.
Oh.
I see it. I see it.
No, it actually is really fun. Because you were, did you do it? No, Jack, did you get to do the water balloons last year? Well, I'm not going to be your teacher at the end of the year, so I don't know.
You can wear something out.
Do it in the beginning of November and have some water balloons. That will be less fun for me.
Do it tomorrow. Monday.
Monday, that would be fun. I don't know, it hasn't been that warm out.
Yeah, it's been cold.
Wonderful.
Winter's coming.
All right, guys, let's get to this last page of notes, right?
All right.
Not too much left. Okay, so we are back to a manufacturing company now. They've got this cost equation. Cost equals 25x plus 3,500. So we are now just going to explain what the numbers in this equation mean. So a fixed cost describes the meaning of your y-intercept. So for us, the y-intercept is 3,500 this time. What does that mean for this company?
They have to pay 35 every time, like at the start.
Yeah, like just to get things started, it costs them this fixed amount of 3,500. It doesn't cost them that every time they produce whatever item they're producing, but to get things started, it's like a startup cost. So before production begins, the company will spend $3,500. You always hear that saying, you have to spend money to make money, right? So, then the marginal cost, that is what our slope is telling us about. So for our equation here, C equals 25x plus 3,500, what does the 25 mean?
It's the cost each time something's like one item's produced.
Yep, so every unit you make, you have to add $25 to your total cost. Okay. So cost increase per unit to produce. Or you can think $25 for every unit. All right, so now we're going to look at some Starbucks data here. So the sales per share was $15.71 in 2011, $17.75. I think that's supposed to be in 2012, not 2012.
That would make it a little bit
Yeah.
interesting though.
So we're going to write a linear equation that gives us the sales per share in terms of year. So really what we're looking at here, if you remember from Algebra 1, to write an equation, you just need 2 points. So we have 2 points because we have a year and the cost, and then we sort of have another year and the cost. All right? I am going to let t equals 11 represent the year 2011. Okay? So t is my year. Y is going to be my sales per share. So I'm going to just write down these 2 ordered points over here. I've got 11 and 15.71, and 12 and 17.75. So what's one thing I definitely need to write the equation of a line?
So,
Slope. Can you find slope if you've got 2 points? All right, so our slope. We're going to do our 17.75 minus 15.71 over 12 minus 11. What do we get?
2.04.
Okay, 2.04. Now we need to actually write the equation. So we went over point slope before. Remember that's that y minus y1 equals m times x minus x1. So which point do you want to use?
11.
Okay. It does not matter in the least. You can pick either point and use 11. So you're going to do y minus 15.71 equals your slope of 2.04 times x minus 11. Oh, and what should I be using instead of x? What variable did I say I was going to use?
T.
T. Okay, make that a t. Okay, so you need to solve that for y. How do you do that? Yep, distribute your 2.04 on the right and add that 15.71. So you're going to have y equals 2.04t plus, or I'm sorry, minus what? Okay, and then you add 15.71 to that. Does that make sense, guys? Is it okay that I'm skipping
Yes.
steps? Okay. Because you had negative 20. So this tells us the sales per share is increasing by $2.04 every year. Okay. All right, how are we going to estimate it for the year 2013?
We put 2013, 13 is 2.
Okay, yeah, be careful. Don't plug in 2013. You'll get a very large number. Plug in 13 for T. So we are doing 2.04 times 13 minus 6.73. It says compared to the actual. I won't make you look it up since you guys had so much fun with Google. The actual was actually 19.77. So pretty close.
This stuff actually works.
Crazy. Okay. All right. One more. So we've got the diluted earnings per share for Tim Hortons. Everybody needs some donuts. All right, so you've got, again, do you guys see the ordered pairs that you have here? Okay, so we're doing the exact same thing. So I want you guys to try this time to come up with your linear equation and then predict it for 2009.
Is this your room? Are you not around there anymore? That's nice. That's a lot of kids. Look at the food classes. I just want to work my Spanish. It's really large. Oh, that was really nice. Oh, just, negative 24, we really add 1.4 against the board. Let me look like 4.97.
Look at here, guys. Most of you were there. Yeah, so guys, those of you especially who didn't have your calculator while we were going through the lesson last class, I did post a video of class which will show all the calculator keystrokes. So if you were struggling with all of that, that's up there now. Okay. So guys, I don't think any of you noticed that the answer to A was given to you over here. Here's the equation. And then for 2009, there's the answer, 1.67. So good job, guys. I know, no one looked at the graph. We should never look at graphs. All right, so that is the end of our notes.